England, 1943. Rain hammered the hardstand at Thorpe Abbott's like bullets against steel, turning the airfield into rivers of mud that swallowed boots and hope alike. Technical Sergeant Paul Chrisman stood beneath the belly of a B-17, grease blackening his hands, water streaming down his face, staring at something every engineer in the Army Air Forces had overlooked. The plane's fuel system was starving itself, and he was about to be called stupid for knowing how to fix it. The bombers were dying over Germany. Not from flak or fighters, though those killed plenty. They were dying because they couldn't reach home. Fuel starvation at 20,000 feet, engines coughing and failing, crews bailing out or crash landing in enemy territory or the North Sea's freezing waters. The numbers told a brutal story. Of every 100 B-17s that crossed into Germany, 12 never came back. The official reports blamed enemy action. Chrisman knew different. He had been watching fuel consumption charts for months. The pattern gnawed at him during briefings, during missions, during the sleepless hours when the bombers returned with gauges reading empty and pilots swearing they should have had fuel remaining. Something was wrong with the transfer system. The auxiliary tanks in the wings weren't feeding properly. Fuel sat trapped while engines starved. The math was simple. The solution would sound insane. Dawn broke cold and pale over the base, fog clinging to the runways like smoke from distant fires. Colonel James approached through the mist, his breath visible in the morning air. Behind him, 3 B-17s sat ready for a maximum-range mission to Schweinfurt, their ball-bearing factories critical to the German war machine. Chrisman had requested this meeting. His hands still trembled from the night before, from calculations run a dozen times, from the certainty of what he had discovered, and the terror of proposing it. The modification was absurd on its face. Every aviation engineer, every Army regulation, every manual written by Boeing's best minds said fuel flowed one direction through the transfer system. Auxiliary tanks in the outer wings fed inboard through mechanical pumps, moving toward the engines in a carefully designed cascade. Chrisman wanted to reverse it. He wanted fuel to flow outward first, filling the wingtip tanks completely before feeding the engines. Against all logic, against all conventional wisdom, against gravity itself at altitude. Colonel James listened in silence, his jaw tightening with each word. Rain began again, soft and steady, pattering against aluminum skin and pooled grease. When Chrisman finished, the silence stretched like wire ready to snap. A captain standing nearby muttered something about court-martial. A lieutenant laughed, short and bitter. This was how you ended careers. This was how you got men killed. But the colonel had flown 30 missions. He had felt engines quit with fuel gauges showing reserves. He had watched friends spiral down because their wings held gasoline they couldn't reach. His eyes moved from Chrisman to the waiting bombers, their props still, their crews not yet aboard. The decision formed slowly, visible in the set of his shoulders, the way he looked at the fog-shrouded runway where so many had departed and not returned. 3 aircraft, 1 test mission. If Chrisman was right, they would gain range no analyst thought possible. If he was wrong, 3 crews would ditch in the ocean, or crash in German territory, and a sergeant would face charges for criminal negligence. The colonel signed the order. The ground crews began modifications immediately. The work was crude and fast. Chrisman directed mechanics through the fuel system, reversing valve orientations, rewiring pumps, recalibrating the sequence controls. They worked through the morning as mission briefing occurred in the operations building, as navigators plotted courses and bombardiers studied targeting photographs. By noon, the modifications were complete. By 1300 hours, crews were boarding. By 1400, engines roared to life. Lieutenant Robert Phelps piloted the lead aircraft. He had been briefed on the modification with brutal honesty. The fuel would flow backward, filling the tips first, creating a weight distribution that violated every principle of stable flight. His flight engineer, Sergeant William Dutch, monitored gauges with the intensity of a man watching for his own death. The other 2 modified B-17s flanked them in formation. Behind them, 37 standard aircraft climbed into formation, unaware they were witnessing history. The formation turned east over the channel. Below, the gray water stretched endlessly, whitecaps breaking in patterns like scattered rice. Phelps held course as they climbed through clouds that turned the world to milk and shadow. At 10,000 feet, they emerged into sunlight so bright it hurt. At 15,000, they leveled off for the long approach to Germany. Dutch called out fuel readings every 15 minutes. The numbers shouldn't have worked. They did. The auxiliary tanks emptied last instead of first. The fuel flowed outward, filling the wingtips completely before the system reversed and began feeding inboard. The weight distribution shifted dynamically as they flew, the aircraft growing lighter from the center outward instead of tip to center. It created a stability no Boeing engineer had imagined. The wings flexed differently, the fuel acting as distributed ballast that dampened oscillation and reduced drag. Phelps felt it in the controls. The airplane flew smoother, steadier, as if the fuel itself had become part of the wing structure. Over Germany, flak burst in black flowers that bloomed and died against the blue. Fighters climbed to meet them, Me-109s and FW-190s that tore through formations like wolves through sheep. The 37 standard B-17s began taking hits. One fell away trailing smoke. Another exploded in a flash that left afterimages burned against the sky. Phelps held formation as Dutch called bombardier ready. The ball-bearing factories appeared below, gray buildings against industrial haze, and the bombs fell away in a cascade that seemed to float before gravity claimed them. The turn for home began immediately. This was where fuel calculations became life or death. Standard B-17s were already watching gauges, already doing mental arithmetic about ditching zones and bailout points. The modified aircraft showed reserves that seemed impossible. Dutch rechecked his readings 3 times before calling them to Phelps. They had fuel to spare. Not margins measured in minutes. Margins measured in hours. The formation limped home across Germany and France. More bombers fell to fighters. Others struggled with engines damaged by flak, their fuel consumption increasing as they fought to maintain altitude. By the time the English coast appeared, 4 more had gone down. The survivors crossed the channel with gauges approaching empty, props windmilling as engines quit from fuel starvation, pilots nursing them toward any flat ground that might serve as runway. Phelps brought his B-17 down at Thorpe Abbotts with fuel remaining for another hour of flight. The other 2 modified aircraft landed with similar reserves. When Dutch calculated the exact consumption, his hands shook so badly he had to set down his pencil. They had extended their range by 90%, nearly double. A modification made with reversed valves and rewired pumps had just rewritten the rules of strategic bombing. Chrisman stood on the hardstand as crews climbed down from their aircraft. No one spoke at first. The silence held weight, the kind that settles after revelations too large for immediate comprehension. Colonel James appeared from the operations building, walking slowly across wet concrete, his face unreadable. Phelps handed him the fuel consumption logs. The colonel read them twice. Then he looked at Chrisman for a long moment before speaking words that would echo through every bomber group in England. The modification spread through the 8th Air Force like revelation. Within a week, every B-17 in England was being retrofitted. Engineering teams from Boeing flew to Thorpe Abbotts to study Chrisman's work, trying to understand how a sergeant with grease under his fingernails had seen what their brightest minds had missed. The mathematics worked backward from conventional theory. The fuel flowing outward first created a dynamic stability system that reduced structural stress and aerodynamic drag simultaneously. But understanding came later. First came missions. B-17s that could barely reach Western Germany now struck targets in Poland and Czechoslovakia. Bombers that had to turn back halfway could complete full missions with reserves for weather diversions or battle damage. The range extension was revolutionary. The strategic implications were staggering. Targets previously unreachable became vulnerable. German factories that had operated with impunity now burned. The losses changed too. Crews that would have ditched in the North Sea made it home. Aircraft that would have crashed in occupied territory reached Allied lines. The fuel reserves provided margins for mechanical problems, for navigation errors, for the 1,000 unpredictable things that went wrong at 20,000 feet in combat. Death rates dropped. Mission success rates climbed. The entire calculus of the strategic bombing campaign shifted because one mechanic had looked at a fuel system and seen what everyone else had missed. Chrisman never sought recognition. He returned to his duties, working 16-hour days modifying aircraft, training other mechanics, refining the system's implementation. But word spread through the crews. Pilots bought him drinks. Navigators shook his hand. Bombardiers who had made it home on fuel they shouldn't have had found him to say thank you. The gratitude came in whispers and glances, in the unspoken mathematics of survival, in the crews who walked away from aircraft instead of drowning in the channel. The official designation came through in spring 1944. Technical modification, 43 to 27B. Reverse auxiliary fuel transfer system. Required implementation on all B-17 aircraft. The language was bureaucratic and cold, stripped of the human drama that had birthed it. No mention of rain-soaked hardstands or mechanics called stupid. No mention of the colonel who had risked everything on a sergeant's certainty. Just specifications and installation procedures, the revolution reduced to technical manual prose. But in the ready rooms and briefing huts, in the moments before missions when men checked equipment and made peace with mortality, the story lived. They called it the Chrisman modification, though that name never appeared in official documents. They talked about the first 3 aircraft, the test mission, the fuel readings that shouldn't have worked. The story became legend, embroidered with details both true and imagined, but always carrying the same core truth. One man had seen clearly when others were blind. One decision had saved thousands of lives. The strategic impact revealed itself in German production records captured after the war. Ball-bearing output from Schweinfurt and Regensburg fell 70% after sustained bombing became possible. Aircraft production declined as aluminum plants in Austria came within range. Synthetic fuel refineries in Silesia and Poland burned because B-17s could reach them and return. The extended range turned the bomber offensive from a regional campaign into a continental assault. Germany's industrial base crumbled under attacks that wouldn't have been possible before Chrisman's modification. The Luftwaffe adapted, but slowly. German fighters had to fly longer distances to intercept bombers, burning fuel they increasingly couldn't spare. The defensive perimeter expanded while resources contracted. Every kilometer of additional range the B-17s gained multiplied the problems for German air defense. By late 1944, American bombers struck targets the Germans had considered safe, had barely defended, had assumed were beyond the reach of daylight precision bombing. Technical Sergeant Paul Chrisman received the Distinguished Flying Cross in autumn 1944. Unusual recognition for ground personnel. The citation mentioned technical innovation and life-saving contributions, language that captured nothing of the reality. He accepted the medal in silence, his hands still carrying grease stains that never quite washed clean, his mind already working on the next problem, the next inefficiency, the next place where conventional wisdom had failed to see clearly. After the war, Boeing hired him. The other aircraft manufacturers tried to recruit him. The Army Air Forces wanted him for engineering development. He chose Boeing and spent 30 years in their experimental division, his name appearing on 43 patents for fuel system innovations. None achieved the impact of that first modification, the one made in rain and desperation, the one that sounded stupid until the numbers proved otherwise. The B-17s he modified flew throughout the war. Some survived to be scrapped in 1945, their service complete. Others burned over Germany, or crashed into mountains, or settled into the North Sea's cold water. But the fuel system worked in everyone. The modification that had seemed impossible became standard. The range extension that had shocked engineers became expected. The innovation born from one mechanic's clarity became the foundation for every long-range bomber designed afterward. Veterans of the 8th Air Force carried their own memories of Chrisman's work. Pilots who had made it home when gauges read empty. Navigators who had reached targets thought beyond range. Bombardiers who had completed missions that shouldn't have been possible. They wrote letters after the war, sporadic at first, then regular. A correspondence of gratitude that connected men across decades. Chrisman answered everyone. Brief notes, never claiming credit, always deflecting praise. "Just glad you made it home," he would write. That was the mission. The mathematics of the modification appeared in textbooks by 1950. Engineering students studied reverse flow dynamics and distributed ballast systems without knowing the human story behind the equations. The principles became fundamental to aerospace design, influencing everything from jet fighters to commercial airliners. But the origin remained obscure, buried in technical reports and classified mission summaries, known primarily through veteran storytelling and airbase legend. Colonel James retired as a general. He gave one interview about the modification in 1958, speaking carefully about the decision to authorize testing, about the 3 crews who had flown the first mission, about the sergeant who had convinced him to risk everything on an idea that sounded insane. The interviewer asked why he had approved it. James looked out the window for a long time before answering. "Because I was tired of watching men die from problems we should have solved," he said. "Because sometimes stupid ideas are just smart ideas that haven't been proven yet." The reunion came in 1963, 20 years after that first mission. Thorpe Abbotts had been abandoned, the runways cracking under English weather, the control tower empty, grass growing through concrete where B-17s had once lined up for takeoff. But the survivors came anyway. Phelps flew in from California. Dutch drove from Michigan. 50 other veterans made the journey, men who had flown the modified aircraft, who had made it home on fuel they shouldn't have had, who wanted to stand once more on the hard stand where everything changed. Chrisman arrived late, driving from London in a rental car, uncomfortable with recognition, embarrassed by the attention. But when he stepped onto that cracked concrete, the men surrounded him. No speeches, no formal ceremony, just handshakes and embraces, tears on weathered faces, the weight of gratitude too deep for words. They stood together in English drizzle, rain falling as it had 20 years before, and remembered. The missions, the losses, the terror and hope and desperate mathematics of survival. The modification that had seemed so stupid and saved so many lives. Phelps spoke briefly, his voice rough with emotion. He talked about the first mission, the fuel gauges that shouldn't have shown reserves, the smooth flight characteristics that defied expectation. He talked about coming home when others hadn't, about missions completed when fuel should have run out, about the margins of survival measured in gallons that shouldn't have existed. Then he looked at Chrisman and said the words they all felt. "You gave us a chance. That's all we ever needed. Just a chance." The modification remains in aviation history, though its story is often abbreviated. Technical manuals mention reverse fuel transfer systems. Engineering courses cover distributed ballast principles. But the human drama, the rain-soaked decision, the mechanic called stupid for being right, the 3 test aircraft climbing into fog with their crews' lives riding on rewired pumps and reversed valves, that story lives primarily in veteran accounts and military archives. Yet its impact echoes forward. Every extended-range aircraft, every fuel system designed for maximum efficiency, every innovation in weight distribution and aerodynamic stability carries DNA from Chrisman's insight. The principle he discovered, that flowing fuel outward first could create dynamic stability and extend range, became foundational to aerospace engineering. But more than technical legacy, the story carries a deeper truth about innovation and courage, about seeing clearly when others don't, about the moment when one person's certainty can change the outcome of a war. Technical Sergeant Paul Chrisman died in 1987, his obituary brief and unremarkable. It mentioned his Boeing career, his patents, his military service. It didn't capture the missions made possible, the lives saved, the strategic impact of one modification made in desperation and validated by mathematics. The veterans knew. At his funeral, 23 men in their 60s attended, all former B-17 crew members, all alive because of fuel reserves that shouldn't have existed. They buried him in Arlington, though he hadn't requested it. The ceremony was quiet. No 21-gun salute, no flag-draped casket ceremony. Just old men remembering, their breath visible in November cold, their hands trembling not from age but from memory. The memory of engines that kept running when they should have quit. The memory of coastlines appearing when fuel gauges read empty. The memory of coming home. Phelps was there, 84 years old, his voice still strong enough to speak at graveside. He told the story one final time. The rain, the modification, the mission, the fuel readings that proved a stupid idea was actually brilliant. Then he placed his old flight log on the casket, its pages yellowed and fragile, and said his goodbye to the man who had given him 43 more years of life. The headstone is simple: name, rank, dates. No mention of the modification or the medals or the lives saved. But veterans still visit, finding the grave through word passed between survivors, leaving small tokens. A B-17 model, a fuel gauge, a patch from the 8th Air Force. They come to remember, to pay respects, to stand at the grave of a man who saw what others missed and had the courage to seem stupid until proven right. The bombers are gone now. The last flying B-17s are museum pieces, maintained by volunteers, flown at air shows for audiences who never heard them thunder overhead in formations of hundreds. But the principle remains. The innovation endures. And somewhere in every modern aircraft's fuel system, in every calculation of range and efficiency, in every design that moves fuel dynamically to optimize performance, lives the ghost of Technical Sergeant Paul Chrisman standing in English rain, looking at a problem everyone else had accepted, and seeing the solution. The war ended. The bombers came home. The bases emptied and the men scattered and the missions became history. But in that moment at Thorpe Abbotts in 1943, when one mechanic reversed conventional wisdom and made it work, when 3 crews climbed into modified aircraft and proved the impossible, when fuel flowed backward and carried men home, in that moment the future changed. Not through grand strategy or brilliant leadership, through one person looking at a problem and refusing to accept that stupid and wrong were the same thing. That was the mission. That was the victory. One adjustment that sounded absurd and worked anyway. One modification that saved thousands and changed everything. One mechanic who was right when everyone said he was wrong. The fuel flowed backward. The bombers flew farther. The war turned on revolutions measured in gallons and validated by men who made it home to tell the story.